Hello everyone. Hello everyone. Today we are going to solve the Leet Code problem number, I think it's 78 if I remember correctly. So it's a Leet Code. Problem number 78. Okay. So this problem is about searching the word where you are given m cross n grid. So you are given a grid something like this, like A, B, C, E, S, F, C, S, A, T, E, and E. Okay, and you need to search the word. So you are also given a word which is A, B, C, C, E, D. Okay, and you need to search this word in this grid, and if the word is present you need to return boolean true, and if it's not present you need to return false. Okay, so let's see. So to search this word A, B, C, so if we look in this grid, we see we have A, B, then you go to C, then C, then E, and then D. Right, so we have this word present in this grid, which is this. So the answer for this will be true. Okay, let's take another example. So here you are given a grid A, B, C, F, S. Let's assume that it's the same grid, but the word this time you need to search different word, which is S, E, E. So if you look in this grid, we have S, but if we look at the neighbors of S, the neighbors of S are A, F, A. We don't have E as one of the neighbor of S, so this is going to return false. Okay. Now let's take the same grid, and this time you are given word A, B, C, B. A, B, C, B, and you need to search this word in the grid. So if you start from this A, we have A, we have this A, okay, we have this A, from A we go to B, from B we go to C, then we have B, but the neighbors of C are E, C, and B. We don't, I mean, this B is a neighbor of C, but it is already visited. So here I mean you so in this problem it is also given that you cannot I mean, the same cell or the same letter may not be used more than once. So that is also given. So that's why we cannot go like this A, B, C and then come back to B. So we don't have it here. Let's start with this A. If we start with this A, the neighbors of A are S, F and D. No, I don't think so. This word is present. So this is going to return false. Right? So in this problem, if we want to categorize this problem, we can categorize this as a graph problem, because what we are doing is we are traversing this matrix in the form of like a DFS traversal, and at each traversal we are checking the neighbor of each letter, and we are comparing it with the character in the word that we are at. So the first thing is it's a graph problem. So it's very important for you to find what kind of problem it is. Now in the graph, what exactly we are going to do? So what exactly we are going to do is we are going to do a DFS traversal to solve this problem. So when we do the DFS traversal, we also need to have this visited array, because we don't need to visit the same cell again. So we need to have a visited array. We need to do a DFS traversal. And the other thing, if you will notice here, is the word can start from any of the cell. It's not like we start DFS from this cell and we need to start DFS from each of the cell. From each of this cell, and we need to check if that word is present or not. And when we start the DFS from each of the cell, we also need to reset our visited array, right? Because if I'm visiting this A for this word, I'm visiting A, B, C. I have marked this as visited when I'm starting with this cell. And now, for example, there is one more. Instead of this F, there is A here. Okay, let's assume. So we have a matrix something like this: A, B, C, E, S, A, C, S, A, D, E, E. So I'm starting DFS from here. So I'm marking this cell as visited. So it's marked as true. I'm marking this cell also visited. True. I'm marking C as visited. True. Then from here, I need to A, B, C, B, A, B, C. Let's make this as B. A, B, C, B. Or maybe A, B, C, B. Okay, let me change this to A. Let me change this, okay? Example is more intuitive and I can explain what I'm trying to explain, okay? Okay, so A, B, A, B, C, C and B. Okay, so when I start DFS from this cell, so I'm trying to search for this word. So I go A, then I go to B, then I go to C, and then I see, okay, the neighbors of C are C, E, and B. B is already visited, and I don't see B as one of the neighbor of C. So this C will return false, okay? When I'm visiting A, I have marked this as true. When I visited B, I marked this as true. When I visited C, I marked this as true. But when I started DFS from C, the recursive DFS from C, it says, oh, none of my neighbors are B. So this will return false to this, and when this will return false to this, it will return false here, 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 okay, right? So the word is not found at this point. But then when I start DFS from here, A, B, C, B, okay, when I start DFS from, let's say, from here, okay, I'll mark this as visited, so I'll mark this as true, and I can still go this way, right? Because whenever I start DFS from each of the cell, I need to reset the visited array. So this will be false. So I go here. So A, B, I'll mark this as true. A, B, C. And again, I don't see any neighbor B as B is not in the neighbor of C. So it's going to return false to this A. So like this, I'm not able to search word. But if I start DFS from here, and if I go this A, B, C, B, yes, the word is present. So every time whenever you start the DFS from each of the cell, you need to reset this visited array. And yes, you need to reset that visited array, or you can also do when you are backtracking from the DFS, when it's returning false, you need to change all this true to false. When it backtracks with a false value, you can change all this true value to false value. And if we find that word while doing a DFS, right, we're gonna return true. Okay, so let's see what we are going to do. Okay, so since we are doing a DFS here, starting from each cell, right? So since so there will be two for loop, and we're going to iterate through each of the cell, and we're going to start the DFS, right? So if the matrix is n cross m, the size of the matrix is n cross m, we'll have two for loop n cross m, and we're going to do DFS for each of the cell. Now what is the time for this DFS? Okay, so this DFS will go, it would be the length of the word, whatever the word is, it would be the length, at the max it would be the length of the word. And whenever we are going through each of the cell, each cell will have three neighbors. For this cell, right, for this cell it will have this as a neighbor, this as a neighbor, or let's say for this cell it will have this as neighbor, this as neighbor, this as neighbor, this as neighbor. So it will have four neighbors. One of them will be visited because we are coming through that cell. So, and let's say the length of this word is L. So we are going to visit L cells, and each cell will have at least four neighbors. One of them is the neighbor which is already visited, so we are not going to visit it. So it would be 3 raised to L, right? Because each cell will have three neighbors. One is already visited because we are coming through that cell. And what is the space complexity? So we are using a visited array whose size will be n cross m. And what else we are going to do? And the recursive call stack for DFS, right? Recursive stack trace for DFS, or recursive call stack for DFS, which will be of the size, the length of the word, which is L. So that would be our space complexity. So our time complexity will be O of n times m times 3 raised to L, and our space complexity is O of n cross m plus L, right? So that's that. And let's look at the pseudocode, and then I'll write the code for this problem. Okay, so the pseudocode is, you are given this character board, or grid, and you are given this string word. And you need to return bool if the word is present. Okay, so what you are going to do is, first you are going to iterate through this grid. So there will be two for loop. One will be iterate through rows, and another for loop for call, and you are going to call the DFS in this for loop. Okay, now this DFS is going to return a boolean value, true or false. Okay, so if this DFS returns the value of true, then you return true, because that means the word is present, and closing all the for loops. And if it returns false, then if we have iterated through all the cells of the grid and it hasn't returned true, that means the word is not present, and we're gonna return false. Now in graph, the code for DFS is very common. So our DFS function, it's gonna take the cell from which we are starting the DFS. So we have our row and the column from which we are going to start the DFS, and then we'll have the visited array, bool visited. Okay, we have this visited array, we have our string word, and we are going to start, the I is the index, it's pointing to the first character of this word, and then we have our grid, right? So when we start the DFS, we need to see if the first character of the word matches with the given cell we are starting with. So we need to check that if grid of this row column is equal to word of I, or word dot character at I. Right, I'll just say word of I. If there is a match, we're gonna mark that cell as visited, right? So we are going to mark it as visited of that row and column is equal to true. Okay, and what else we gonna do? Now if that character is the last character of the word, then our search is complete, right? So if I is equal to, if the index I is the last index, then we're gonna return true, because we found the word and our search is completed. Okay, now if that word is some middle character or the first character, so The first character has been matched. Now we need to look at all the neighbors of that character in the grid. So each cell has 4 neighbors. So we'll write one function neighbors get neighbors, which will return us all the neighbors, and it's gonna return us the row and the column index for neighbor. So get neighbor. This function will return all the neighbors of this cell. Okay. Okay, and we're gonna see that if this neighbor is not visited. Okay, so if it's not visited, this is row and this is column. If it's not visited, then we are going to do the DFS. So we are going to do the DFS starting from this row and this column. The argument will pass as in, but with that we're going to increment that index. So this will point to the next character in the word. We're going to start the DFS. But what happens if this DFS return true? That means it's saying that I have found the word, right? So so this neighbor has already found the word somewhere. I mean, from this neighbor they already found the word. So this DFS is returning true. So we also gonna return true because the word is found, right? But now, for example, if the word is so we also gonna return true. But if the word is not found, I mean if this is not matching this cell, the character that we have in this cell is not matching with this character. The character that we have at the ith index is not matching. That means we're not gonna go in this if loop because the characters aren't matching. So what will return? We'll return false, right? But before returning the false, we are going to return false, but or let's say that the character is matching, right? But then we mark that cell as a visited. But when we do the DFS down the line, the other characters from the word are not matching, and this DFS never return true. None of the DFS for all the neighbors, right? Like for character A, like we are searching word A, B, C, and we match character A. We mark that cell as true, and then we looked at all the neighbors of A, but the neighbors of A are something like this, and none of them match, and therefore none of this DFS return true. So we never gonna do all this, so then also it should return false. But since we mark this cell as true, we need to reset it, right? Because as I told you, whenever we do DFS, here at this point our visited array should be all false. So we need to reset that visited array. So before returning false, when you return false, outside all this if condition, before that you need to mark that visited of that row and column when you are backtracking as false. Now in case of true, when we are returning true, we don't care about changing the visited array to false because we already found the word and we are returning true, and we're gonna return true from our DFS, and the DFS will end here, right? And in this here the DFS will end as soon as it returns true. So this is one way we are resetting the visited flag before backtracking. The another way to reset the visited flag is you can initialize the bool visited every time here. And you can pass it in the DFS function, whatever the rules and codes are. Okay, and you can pass this DFS function. So that's one way for doing this. So every time you start DFS from each of the cell, your visited array is all false. And if you don't want to do it this way, you can also do it this way. While backtracking, you need to mark that as false. So let's write the code for this, because let's write the code and see how it looks. So I'm going to write code, and I'm going to write that in Java. A language doesn't matter, but I'm just informing you that I'm going to write it in Java. Okay, so let's say we are given, does word exist? Okay, so we are given the return type is boolean, word exists, and we are given grid, which is a character grid, and we are given the word that we want to search, and so we need to start DFS from each of the cell, right? So let me see how many rows and columns this grid has. So rows is equal to grid dot length num rows, and columns is equal to grid of 0, that is 0th row, and whatever the length of that row, that many columns we have. Okay, so once we are done with that, we need to write 2 for loops. I mean, we need to visit each cell and we need to do DFS. So I'm going to write 2 for loops for integer I is equal to 0, I less than num rows I plus plus for integer j is equal to 0, j less than num calls j plus plus. So I'm writing this through for loop so that I can start my DFS from each of the cell to search for the word. So for starting the DFS, I need to tell my DFS which cell I'm starting with, which is I and J. That's the cell I'm starting with. Another thing is I need to give my DFS the word that I'm searching. The index, I'm going to start with 0th index. I need to pass the grid. What else I need to pass? Anything else? And I need to create a boolean visited and pass that. Okay, so here I'm going to create that, which would be boolean visited is equal to new boolean num rows and num columns. Okay, now if this DFS returns true, that means the word is present in the grid. in that case we are going to return true. Okay. But we have looked through all the cells. We have started DFS from all the cells and we are not able to find the word, in which case we are going to return false. Okay. Now let's write the DFS function, which would be public. The return type is boolean. Now this is the cell from which I am starting my DFS, so that's the row in the column. Then I have string word, integer I, character, grid, boolean, visited. Okay, so I need to see that if the character is matching. So if the character which is there in this cell is equal to word dot character at I. If they are matching, then only I'll proceed with the DFS. Okay, if they are matching, then I need to mark the visited. I need to mark that cell as visited. So I'm going to mark that as true. But what if this is the last character of my word? So if this is the last character of my word, I'm finished doing the comparison and I have already found my word in the grid, in which case I'm going to return true. Right? Now if this particular cell matches, then I'm going to look at all the neighbors of this cell. So I'm going to look at all the neighbors of this cell. This get neighbor function is going to return me the row and the column for all the neighbors of this cell. Okay, and when I look at the neighbor, for example this first neighbor, I need to see that that neighbor should not be visited. So that's the zero. I mean this is an array, so 0 index holds the row and index 1 has column. So if it's not visited, then what I'm going to do, I'm going to do DFS again from that cell. So it's a recursive DFS. But what if that DFS returns me true? So I'm going to do DFS from that cell. And I need to do I plus 1 because now I'm going to compare the next character. But what happens if this DFS returns true? That means the DFS that I've started from that neighbor, it has already found a word. So I'm going to return true. I'm going to do that for all the neighbors, okay? If any of the neighbor has found the word, you're gonna return true. But what if I have done for all the neighbors and I'm still not able to find the word? Right? Then I need to return false. But before returning false, remember, you need to mark this visited for that cell as false, because when we start another DFS from here, from this outer for loop, this for loop, we might need to visit that cell again, and if it's true, we're not going to visit that, so we need to mark that as false. right? When we are returning false, we need to revert that. I mean, while backtracking, we need to reset this visited flag. And if you don't want to do this, you can also do something like this here. Visited is equal to new. Every time you start DFS from the cell, you reset this visited. You can do this also. Okay, so either or, don't do both, just do one. While backtracking, you can mark it as false, or every time you can initialize it with a fresh copy. Sorry. Okay, so that's DFS. Now let me write the get neighbor function. The neighbor is going to return the list of all the, it's going to return all the neighbors, but in the form of rows and columns. Okay, and it's going to return the index of them. So it's a list. The list will have the row and column. So get neighbor, and this is row, this is column, and this is the grid. So if you look at any cell, right, any cell, right, it has 4 neighbors. Okay, the first neighbor is the top cell, bottom cell, left cell, and the right cell. So the top cell is at whatever the row index of that cell minus 1, and the column will be the same. For the left cell, whatever the row will be the same, but whatever the column we have, we need to do minus 1. And for the right cell, the row will remain again the same, but for the column we need to do plus 1. And for the bottom cell, the row will be plus 1 and column will remain the same. So what I'm going to do, so this is my result that I'm going to return. I need this count of number of rows, and I also need num calls. So what I'm going to do is I'm going to iterate through this ngp, and the value for my new row and column will be my current row plus n of 0, which is this value. Just let me show you that. Where's my mouse? That's it. Anyways, it would be n of 0 and column will be call, which is my current column, plus n of 1. But then I need to check that they are not going out of boundaries. So this row should be greater than equal to 0, and it should be less than num rows, and my column, so it's this value, I'm adding this value, n of 0 and n of 1, and my column should also be greater than equal to 0, and column should be less than num calls. Okay, if it's within the boundary, then I'm going to add it to my result. So that would be equal to row and column. I'm going to add to my result. And then I'm going to return result. That's it. So that was the get neighbor function. So in this problem is really the DFS and graph. There's no change to that. It's just the